Homework busy? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
Question 41 states that the negative kaon particle has a charge of negative E and contains one quark and one antiquark. Part A of the question asks, what quarks can the particle not contain? So part A asks, what quark can we not have? Quark. So one thing we can do is if we look in our textbook, I believe I had it up here, we see from table 32-4, so 32.4 I should say, for the table. It provides, if you don't remember already, the charge of the quarks and antiquarks. So one thing we know, there's one quark and one antiquark. So we know that the charge of the quark plus the charge, I'll just call it the antiquark, has to equal negative E. So any quark that we choose, an antiquark has to sum with that quark charge to equal negative E. So since if you look at, again, table 32.4, if we were to choose a quark with a charge of positive 2/3, so charge equals plus 2/3 E. Well, this is what I'm posing. If we were to choose this, then we would need the charge on our antiquark to sum this with this to be negative E. So that means any antiquark, has to have a charge of negative 5/3 E, not Q. 5/3 E to sum, so the total charge has to equal negative E. But if you look again in that table, this does not exist. So that means question A does ask again, what quarks cannot be chosen, right? Let's say what quarks can the particle not contain? So that means we can't have any quarks that have plus 2/3 times the charge. So that means we cannot have, so we can't have quarks, an up quark, a charm quark, or a top quark. So that'll be your answer for part A. And part B, similarly, just asks what antiquarks can you have? Which antiquarks can the particle not contain? I'll call this AQ. Well, by that same logic, because it needs to sum to it needs to sum to -1, excuse me. If we have the antiquark, so the charge on the antiquark, I guess I call it capital A before, if that were to equal, let's say, positive 1/3, that means the charge on the quark would have to be -4/3 times E. Which again, if we look at our table there, that does not exist. So any antiquark with a positive 1/3 charge we cannot have. So that means, with that logic, we can't have, let's see, anything with positive 3, which is an anti-down quark, anti-strange quark, and we cannot have an anti-bottom quark. So there you go. If you're curious, if you look it up, the quarks and antiquark it does have is a strange and an anti-up quark. That's a combination. If you double check that, -1/3 -2/3 is -1. So there you go. So this question was, what can't you have? So we had to look for combinations that don't exist, in which the only ones that were impossible were the following that we found. There you go.